Hey guys, welcome back to Home Built, and this week we are back on the bed of the Frankenhauler, and this week we're going to start making it tilt. All right, guys, well, before we get into it this week, I want to take a quick second out to thank this week's video sponsor, which is HOTWAV with their R9 Ultra 5G tablet. So this thing comes with this awesome aluminium stand, carry handle, and also a leather strap. It has this super bright 350 lumen camp light. It's able to record in 4K and also stream 4K movies, etc. It also has the 20 megapixel night vision camera inbuilt.
And I really love that it comes with a stylus, which I find super handy.
It also has a huge 20,000 milliamp hour battery with 20 watt fast charging. But what I think I'm going to be using this for the most is because this is a rugged, made for outdoor use, I'm going to really use it here in the shed because it's resistant to dropping, dust, and fluids, so I can actually use it, and I'm going to set it up in here when I'm working on my cars. The amount of times I need some sort of reference, I'm looking something up on YouTube, and I can set this up and have it here as reference while I'm doing my work. And I'm sure plenty of you have wanted to do the same thing. So go and check it out. If you're interested, I'll put a link down in the description, and you can check out the HOTWAV R9 Ultra 5G for yourselves. And as always, help out the companies that help out the channel. All right, let's get back into it. All right, guys, welcome back. And if you were watching last week, you will have seen that I did a whole bunch of work starting to build the base frame for the bed of the Frankenhauler. If you missed it, I'll put a link up above so you can catch up. And like always, do those things like subscribe, comment. As I said previously many times, that really helps out that crazy algorithm. So last week, as you might have seen, I built this initial structural frame for the base of the Frankenhauler's bed. Now, the bed is going to sit on top of this. It's a little bit hard to explain at the moment, but it will make more sense as we go through. But when I made this last week, I got to the end of the week and I realized that by welding in the hinges onto the ends here and also these two reinforcing bars up here for the where the hydraulic ram is going to be attached, the top tube bent. So this center section from about here to here is still nice and flat, but from here over, because of these welds under here, it tilted this frame down there. And also back here, this curves down. And the first thing I'm going to do this week is I'm going to try and fix my curve problem. And it's not something I've done before, so we're going to learn together. All right, so you may have noticed that I never actually put a final crossbar on the end. I'm still not exactly sure how I'm going to finish up the end of this frame yet. So what I'm going to do, because I want to curve these evenly, I'm going to tack them together. So I need to put another crossbar in here. It may be temporary. I'm going to cut these to the length that I want them to be, and then we'll put the crossbar in, and then we can start looking at doing some flame straightening.
All right, so first things first is I get on and mark out the excess that I've got on these two rails and cut them to length. Now I've chosen 4.4 meters. I think that's a good distance. It gives me a minimal amount of overhang with enough to actually get the cars onto the truck.
All right, so I've welded in my brace across the rear, so now I have the ladder frames all nice and even and held together, which is a important point here because I don't want these ends to start warping all over the place. I want to try and get them back straight again and that will help tie them together this way. So it's only really going to be up and down that they are going to be able to easily move. Now, why does it warp in the first place? Well, essentially, the big issue with welding is that metal expands and contracts when it's heated. I'm sure all of you are aware of this. Now, the issue is that when you are adding all of this weld in, you're adding it in its hottest liquid form, and of course it's in its most expanded state. So you're adding it in to something that is reasonably rigid, but you're adding in expanded metal. When it cools, it contracts, and that is what is bending these bars by that contraction as it's cooling. Now, there are things you can do to avoid warping. There's ways you can clamp things down and stuff like that. In something like this, in my garage, I don't have a massive welding table or any real way to hold this down, but there are ways to get it back again. And basically what I'm going to do is I've got to add heat on the opposite side to where I've welded, and potentially in a bit of a V shape. I've sort of watched a couple of videos on it, and particularly in the corners is where it primarily needs a lot of the heat. And what I'm going to do, I've stuck my lift table under the end of the frame, so that's holding it up. It would work potentially just by heating this and cooling it, but by sticking the lift table under here, it helps that when I heat it up, instead of it just heating and expanding, and it will warp more and then cooling back, it'll expand probably out sideways rather than lengthways, because it's sort of restrained that way. It's sort of forced to expand somewhere, and then as it cools, it will suck everything back in again, and it should straighten this out. So I've got myself one of these little portable oxygen and MAP gas systems. So it's not oxyacetylene, but it gets almost as hot. So it should be better than the other things that I've got around. And I can't justify getting a full oxyacetylene setup because I just so rarely ever use it. But hopefully this little thing will do the job. So what I need to do now is I need to start heating these areas, and let's see if we can get this straight. All right, so before we actually bend it, let's see if we can quantify how much we're bending and if we actually can get it to straighten it all. So I've got my level on here in the middle past this weld. It sits nice and flat, but down here you can actually see there is quite a gap. There's about a 5mm gap at this end. Now, I want to be able to quantify how much I'm doing this. So what I've got is I've just got this little square here, and it's about 2mm thick. So I'm going to slide this in until it stops. And currently, we're up. I'm going to make a mark about here. And I know at the moment, we have 2mm deflection by this point. So hopefully, if I can do a small test, hopefully we move that deflection point further this way. So basically we're straightening it up and this gap will shrink. So let's try that.
So getting out this little MAP gas oxygen torch setup, it's the first time I've tried to use anything like this, and actually I've never used an oxyacetylene either, but I've obviously seen it being used. And the issue I'm finding with this setup is it's got such a tiny torch and such a low volume of gas. The hot area I can create with this little tiny torch is very small. It takes a long time to get the steel up to a glowing cherry red hot surface. So I've gone through here and given it one go, and it didn't really make a lot of difference. So I realised I've got to get it a fair bit hotter than I did. So I'm coming back again and really trying to get this whole section cherry red hot, and then cool it down with a wet rag to see if I can straighten this stuff out.
So this little kit, it takes a while to get the heat up there, but I found getting it to cherry red hot is definitely working. It's taking its time though. So we started up here with my 2mm bar, and even Actually, this is cooling down even more now. It's down to about here. I just measured it a minute or so ago, and it was up to there. So we are very, very close to level now. We are almost there with this bar. I reckon it's about here now, actually. So you can see that gap is closed up a lot, and we are looking a lot better. The other side doesn't appear to be working quite as well. We're getting to the stage where I can pretty much call it good. That's now maybe a 3 mil gap at the end here. One more go, if I can close that up another millimetre or so, I think we're pretty good.
So let's get it out and heat it up again, and again trying to do just a little bit more shrinking to try and tilt these bars back to a straight piece again.
All right, I think this has straightened it out a hell of a lot. I don't know if it's 100% done yet, but it's looking pretty good. I'm going to head down the other end now and see if we can do something about the curvature down there.
All right, so moving on down to the front, and you can see I'm marking out my initial starting point, the same as I did on the rear, and just getting out the torch and trying to heat it. And you can see that I'm out of gas.
All right, well, I had to go up the other end and ran out of gas. This is really not, it's a toy kit, and it really did not give me too much time working on this. I think a proper oxyacetylene would be better. I might have a little quick play just using the TIG and see if I can get the TIG torch to heat up the area without actually melting the surface. So I've got to turn it right down. I'll have a bit of a play with some scrap bits of box to get the settings right, and I'll see how it goes. I don't like the idea of using the TIG, but as long as I'm just using it to heat the metal up, I think that should be okay. So let's give that a go.
So I've got this little spare piece of the same box, and I am just running through with the TIG and heating it up. The issue I think I'm finding is that the TIG, whilst it can get it very hot and get it totally to melt, to get it cherry red hot without actually marring and distorting the steel on the top, that is the issue, and it's doing something but not enough.
All right, so I used the TIG method on here. So basically, I didn't actually penetrate. I just sort of heated up the surface, and you can see here, so just basically slightly oxidizing surface, tiny little spots where the very top of the surface did pull slightly, but I didn't melt the whole piece. I didn't weaken it. I think I just heated it up, and this has actually been quite effective. In one pass with the TIG, that is where I could get my my little feeler gauge to last time, and now my feeler gauge is getting to here. So I have straightened that up quite a bit with one pass of the TIG, and to be honest, I'm pretty happy with that. There's about 3 mil at the end of deflection. That is nothing. Same on the other side. It's also it's still cooling down, and it's getting better as it cools. Yeah, currently the old mark is here, the new mark is there. So it is straightening it out. And to be honest, I am happy to call it a day. All right, so last week you saw that I put in these 2 heavy duty bars up the front here for my hydraulic ram. Now this is my hydraulic ram, not light, but that is going to be able to lift this up out of the way nicely. So what I need to do now is I need to make the mounts for the ram. Now, I worked out with a whole bunch of calculations that I need to sit the ram on a 45-degree angle to connect up to this ladder bar. And that is basically so that it has plenty of clearance to the tail shaft, because the tail shaft is almost in the middle. It's actually not in the center, it's actually offset. But the ram is going to be in the dead center, and at 45 degrees, I get just that little bit of height extra with the ram, so that it will stay well out of the way of the tail shaft while the vehicle's driving, and then when lifts up, it can push the ladder frame up and out of the way. Now, there's not going to be a whole heap of weight on here. Imagining the tray and everything and a maximum 1,500 kilo car, say the whole thing is 2 tons and half of it's going to be on the back, it's probably only going to be lifting a ton. This is a 10-ton capable ram, so there's plenty of movement there. There were people concerned that it's facing at a 45-degree angle, it's going to be pushing it this way, and I should have had it pushing back that way. For starters, I couldn't have fitted it. That was the way it had to go to fit, because I've got this crossbar here on the frame. There's no way I could have fit it back the other way, and it needed to be work out where I could get the height right and the pivots right and all that sort of thing. There was lots of calculations about where the ram goes. It wasn't just sort of, I'll just slap it in here and hope it's good. There is lots of thought that's gone into this. So now what I need to do is I've just moved the brake lines that are sitting down in here, and they're out of the way, so I can now box in the frame just here. Again, it's not going to have that much weight on it. It's actually a much chunkier frame here than it is at the back. At the back, the frame's only about 100 mil high. Here, it's 130 mil high, so it's much chunkier this side of the diff. So let's box this in, and then we can start working out the mounts for the hydraulic ram.
Alright, so some 3mm box section, and I'm using this piece here. It's the right length for boxing in the frame, and I'm going to cut this into quarters. In hindsight, buying some angle iron probably would have been easier, but in this case, this is what I've got. And the reason for this is that the frame rails are 130mm apart, and I don't have a 130mm box section. So here are some spaces that I've made up, and this is actually a really good tip I got from Grindhard Plumbing Company on cleaning the slag off of the leftover plasma table bits, is just using the air hammer. It's a lot quicker and easier than going around and trying to grind it all off, and it's quite effective. And hopefully now you can see how I am making my 130mm high boxing sections. Essentially welding my angle iron pieces top and bottom, if you like, and joining them in the middle with the extension bits gives me that 130mm high section that I need. And yeah, going through with the TIG on the inside and the outside, these things are super stout and should do the job nicely. And now that they are all cooled down, I can mount them into place, make sure they're all perfectly neat and square, tack them in, and then I can weld them in solidly with the MIG. And a bit of weld through primer on the inside, and do the same again on the other side.
Alright, so I have now boxed in the rails at the this section here, and over here you can see I had to step these plates up, and to be honest, the amount of force that's on these rails, I would have been happy with them unboxed, but boxing them in is overkill. It doesn't take that much extra work, so it's worth doing, but I think they'll be more than suitable. So now we need to start mocking up where my hydraulic ram is actually going to go and see if we can sort of get it all in place so we can start making the mounts for the ram.
And this is where all those measurements, CAD drawings and designs come together to see if it all actually lines up the way that I planned it to, and if it's all going to fit and work.
Alright, so this is very loosely mocked up how my hydraulic ram is going to sit. So I have 2 crossbars. They're nice, big, chunky 3mm 100 by 50 box sections. And I'm going to have 2 of these massive 100 by 50 by about 6mm bars going across the mounts actually going to be on. So same stuff as we've got here, just they're going to be here. Now remembering, this is only going to be pushing about a ton, so at max. So it's massively overkill. The bottom of this ram is going to have still about 50, 60 mil between here and the tail shaft, and that is when the ram is up. So it's never going to be up when the drive shaft is running. when it's running, it's going to be up even higher. It's going to be, 100 mil or so off, because basically I need to have it tilted like this. So this end needs to sit low enough. So you can see here, I've got a gap on there. If I turn it around so you can see, there's probably about 30 or 40 mil there. I want enough space so that when the tray is sitting on here, we're going to have a little step up, about a 10 mil step up with the plastic tracks and then the ramp. And I need to be able to have the attachment point for the winch in the center as well. So this is in the center. The attachment point for the winch onto the bottom of the tray needs to be up here somewhere as well, so it can travel over the top of this. And this needs to be able to sit down. So the whole thing is going to be somewhere probably about here. So for the mock-up purposes, what I need to do now is I need to start making up the braces that actually hold this pin to this. So it's time to get into CAD, do some measurements, and see if I can plasma cut out some sort of bracket that this will be able to bolt into.
So I start by using some bits of timber to prop up the RAM at the angle that I need it to be, and then start doing some reasonably accurate drawing and measuring and calculating before going onto CAD and starting to design up the brackets that I'm going to need. And it's a lot of backwards and forwards and just double checking, and being able to do this right next to what I'm working on makes it so much easier, so I can make sure that everything is correct, and then we can send it over to the plasma table. And I know this is such a luxury to be able to have this, and I'm extremely grateful to World Class for looking after me with these things, because this makes my life in this situation so much easier.
All right, that is an initial mount. So we have a mount here, but I really want to brace it back to across these two poles. But this gets in the way. I can't make it come up too high, so I'm sort of thinking about it now. And I just wanted to mock up the initial part. These are going to be thicker, and this is just for testing purposes. So now I need to have a bit more of a think and see how else I can make it, so I can brace this across these two and make this the strong mount I need it to be.
And here is the mock-up of the piece that is essentially putting it all into double shear rather than a single shear.
All right, I am pretty happy with that bracket. So this is just a mock-up in a smaller gauge, and I'm going to remake that now. Nice and chunky and solid for both sides. I'll probably do double thickness, and that will make a very decent, strong mount for my RAM. So let's cut some of them out.
So now let's cut these out of some nice thick 6mm plate, and this first one goes very nicely and smoothly. And then partway through this second one, the breaker in my shed trips, and that puts paid to that. And what I didn't realise is that it also tripped out the breaker on my compressor itself, and so I'm running lower and lower on air pressure, which is making the cuts worse and worse, and I don't realise it, and I even try and cut this out a second time, which doesn't work properly. And eventually I have a couple to work with to start with, and go over and start fitting them up and tweaking them and making sure they're all going to fit nicely, nice and tight onto my hydraulic ram.
All right, so I have these two braces made up here. I'm quite happy with them. They're 6mm plate, couple of holes for adding some lightness. And I'm going to actually double these up. So I'm going to have two on either side. And you can see this is the thinnest area through here. I might actually, when I cut out the next ones, I might actually make it a little bit thicker through there, because I have a little bit more clearance on this cylinder, because it curves around, and so they're going to be super stout. Again, this is only going to carry a ton, and this is 6mm plate. These things will probably handle it quite easily by themselves, but let's add in some redundancy in there, double them up, and yeah, they're super strong on this end. There's less strength on this end, but that's this is the end where it really matters. So I think that is going to be plenty strong enough for what we need to do. So let's cut out a couple more, and then we can tack it all in, and then we can start looking at what we're going to do about the these bottom mounts, because at the moment this is all just mocked up, sitting there. That is not how it's going to be.
So the issue I have is that running 35 amps through the plasma cutter and trying to run the air compressor on my single phase shed, it struggles. But once I replaced the consumable tip on the plasma cutter, it was all good.
All right, so I have 4 of these 6mm plates now for the top of the ram mount, and to be honest, the bulk of the structure is going to be, and the strength is on this end, on this bar. This is sort of secondary, just sort of basically tying it in. Otherwise, it would have all the leverage going this way. So I'm quite happy with this design. I think it's going to work quite well and be plenty strong enough for what I'm doing. Let's measure it out, tack it in, and see how we go.
All right, so now I need to do some detailed measuring to make sure I've got everything exactly in the center where I want it, and spacing out each of the braces so that they're all nice and evenly spaced and sitting exactly where I want them. Then I can go through and tack them into place, or at least the center too. Then it's on to making the mounts themselves to hold the bottom of the ram, and there's cleaning up the frame rails and then lining up the 2 crossbars that are going to form the base of the ram mount. Now this is mocked up into place, and then I have the 2 crossbars that go opposite again to that, and this is making sure I've got enough room between everything so the ram can pivot and tilt and do everything it needs to. Then it's a matter of going through and starting to drill in the bolt holes. Now I am going to bolt the ram on and off. I need to be able to service it and remove it, so I'm drilling holes all the way through the square tubes. And of course, you don't want to just bolt straight through square tubing. It's not the done thing, so I need to go through and start making up some crush tubes. So I start with some steel tube that the bolts I'm using fit through nicely, cutting 4 lengths of that before fitting them into the bits of square tube. So basically I drilled a small hole on one side that the bolt just fits through, and then the bigger hole so the whole new round tube will fit in from the other. This way I can weld them in from the bottom, and they are all nice and solid all the way through, and I can bolt the bolts up as tight as I like, and I'm never going to crush this square tube. And just grind them all off nice and flat, and we have some nicely prepared cross tubes.
All right, so these are going to be my mounts for the ram, and as you saw, I drilled these out and I welded in some steel tubes in here, so crush tubes, because generally you don't want to put a bolt through a bit of square tubing because you could potentially crush it. So by welding a steel tube into these, it's going to try and squeeze the tube lengthwise, and it's going to save these from crushing. So I've got these done. Let's tack them on, and hopefully we should be rampart mounted.
So wrestle the ram back into place again. It's quite heavy, but it needs to be to do the job, and yeah, bolt it all up, and then I can get it in the right spot, make sure the measurements are exactly correct, and then I can tack it all in.
All right, so we are all tacked together. So again, this is only tacked just so that if I do want to make changes, I can. I want to cycle it all before I go through. These outer 2 pieces are going to be spaced out apart, more like that, but they're not welded on yet because I want to be able to weld the inside one completely before I then weld on the outside one. So yeah, we'll wait for all of that. But at this stage, we are looking really, really good. So now we need to mount the pump somewhere. Now, I've been having a look, and basically behind the cab on this side, we've got the battery trays here. So I'm going to put my spare tyre into this space here. I've worked it out. I've got a nice position here that the spare tyre can sit. Now you are going to have to lift the bed to get to the spare tyre, but the way that I sort of figure it is if you're going to have a blowout, the engine is still going to be running. If the engine's not running, then you're not going to worry about it. And if the engine's running, then the hydraulic ram will be working. If the hydraulic ram is not working, then I'm probably not driving the truck until I get that fixed. So that's the priority over blowing out a tyre. So I think I'm quite comfortable having that there for that situation. Now coming back on the sides, we have this space here. Now I am going to have running boards going the whole way along the side of the truck. I am going to have the old style wheel arches over the wheels. I do have something coming for wheels. I am thinking that along this area on this side, on either side, will be cargo boxes. So I'm thinking that I'm going to mount the hydraulic ram outside on this part here so that it's easily accessible so that if there's any issues, I can get to it and service it. So let's go over there now and see if we can make some sort of mount for the hydraulic pump.
So scratching my head to work out exactly how I'm going to mount this, and I started with some small angle iron, and I'm cutting out bits to length so that I can actually make a little box frame that the ram will sit into. And once I'm happy with the shape of all that, I can get onto the bench and then start tigging it all together. So I have a nice flat square box section. And then using some thicker angle, I've actually got the base plate in the center of this where the motor part of the ram actually mounts, and I am welding that into place as well.
Okay, so I have the pump. It's all mounted in here, and that is looking really good. That plate is going to be attached to the side here. But I need to make up some end mounts and stuff like that. And it's getting close to the end of the day on Friday, and I'm running out of time. So I want to see this actually run and cycle. And I've realized with the length of the hose and where I'm going to run it, I'm going to run it from the top of that machine. It's going to run down and do a loop down in here and then come back. And I want it to enter into this side of the ram. Currently, I've got it set up this way, so I've got to unbolt it, flip the ram over.
So wrestling with the heavy ram again to unbolt it and flip it over so I can get the hose in to the other side of it. But once I've got it all flipped, I can hopefully leave it all plumbed up for good.
All right, moment of truth. Now, this is only just tacked together, so this will be a good test anyway to see how the basic principle is going to work. Obviously, it doesn't have that much weight on it now, but if it's going to break things, it will break it now, and that'll be a good sign of where the weaknesses are, if there is any. So let me see if this does hydraulic things. Hey! We have movement, but we're running out of power. There we go. All right, that's it. Full height. We have hydraulics. Yes. Oh, that's good stuff. That's what we wanted. Yes. Look at that. We have hydraulics. That is going to be a nice big ramp. Oh, that's going to slide the car off beautifully. I don't even need to get it to that height, but that is the maximum height, so that's all good. We'll have plenty of gravity helping us slide the tray all the way off and onto the ground. That is fantastic. Look at that. I made a thing. All right, so overall, I'm very happy with this design. Now, there is going to be end plates on these that are going to tie them in together to lock them into the side of the frame. So this will be all gusseted and joined in with a pretty type of side plate here. There is a lot of concern about having some cross braces in here to help triangulate this and stop it from sort of tilting either way. There's stuff coming for that. Don't worry about that at this stage. But we have a hydraulic system. This is exactly what I was looking for. We have a tilt frame on the bed of the truck. Now, there'll be locking systems and there's all sorts of things to go. There's so much more to go, but that's good. Now, let's see if we can actually lower it. This might take a while.
So I think I have a whole bunch of air in the system, so I have to work out how to properly bleed this cylinder. I don't know if there's any actual bleed nipples or anything on the cylinder itself to make sure I've got all the air out, but I can at least try and bleed the hose.
So at the moment, it's just so light for the weight of that ram that it needs a lot more weight on that end to get it to come down. But once we have the tray on it and the winch that goes up then to pull the tray on and off and all the rest of the gear, it should be a lot heavier and hopefully go down a little bit quicker. But for the time being, that is all we have this week. So I think that means it's time for Fun Facts with Mrs. Jeff.
Hey guys, in 1962, Ford executives led by Lee Iacocca set about to produce a concept car to fill the gap between go-karts and the Corvette. The result was the Mustang 1. Now the body skin was a one-piece unit that was riveted to a space frame. To increase rigidity, the seats were part of the body and the steering wheel and pedals could be moved to suit the driver. Now this compact, lightweight car used the 1500cc V4 out of the Ford Cardinal. The front-wheel drive engine and integrated gearbox were mounted directly behind the cockpit, making it a mid-engine layout. Only 2 prototypes were manufactured, and only one of them was a fully functioning car. The concept attracted a lot of interest, but it was never close to becoming a production car as the manufacturing was too complex at the time. Ford lead designer John Najar, who was an aviation enthusiast, named it the Mustang after the P-51 fighter, and that's a name that continues to this day.
All right, well, I am very happy with the progress this week. We have hydraulics. We have the ramp doing tilting ramp things, which is fantastic. I think I do need to bleed the air out of the line. I think the reason why that ram is going up in pulses is because it's compressing air and that's springing it up rather than actually just fluid, which should just be much smoother because fluid doesn't compress. So,
is that something I'll need to help you with?
I'm not exactly sure how I'm going to do it. I think I might have to take the hose off and put it back into the pump and run the pump so it flees through the hose, but then I don't know how to get it in the ram. I don't know. We'll
we've had bleeding brakes before, and that's been different.
But I think I need to get rid of the air, and then it should hopefully pump a little bit nicer, and also run it on 24 volts. And there's plenty more to do, but we have progress. We have visual progress, which is always good.
Visual progress is enthusiastic, as encouraging, isn't it? It's very encouraging.
It is encouraging.
Yeah. Like and subscribe and let Jeff know what you think of his videos. And of course, Patreon if you want to help him out and see the videos a day with no ads.
Yes.
Very appreciative. And it's very glary, so sorry about all the squinting because it's just like
it's nice,
blinding,
sunny spring weather. It's fantastic.
It's warm, but it's bright.
Yeah. All right.
Nice.
See you next time. See you guys.
No, let me do it again. Almost got it. Produce a concept car to fill the gap. Led by Lee Iacocca, set about to fill the gap. No, set about to produce a concept car to fill the gap. To increase rigidity, the seats were part of the so mounted directly behind the cockpit, making it a mid-engine level drive.
Layout. No, almost. But no. Yes.
Surprise.